In the previous video, we resolved a leak by utilizing a weak reference modifier. In this video, we're going to learn about how zombies can occur while interoperating with C and Objective-C. We'll finish this video by creating a zombie of our own. Zombies occur when we over-release an object by deallocating it more than once, or when we reference an object that has already been deallocated. When using Swift alone, zombies aren't really an issue, but since we, as iOS professionals, may one day be tasked with interoperating with C or Objective-C, we should understand the risks. Let's begin by creating a new Xcode project. Choose a single view application, name it Zombie, and click Create. Open up your storyboard and create a button similar to the last video. And change the label if you like. We'll drag out an action and name it Handle Create Zombie Tapped. At the class level, declare a variable with the type of UnsafeMutable Pointer of type string. I should probably take a moment to describe what this UnsafeMutable Pointer is. This structure is a generic UnsafeMutable Pointer that takes a type of T. This generic wrapper provides interoperability from Swift to this native C type. We use this type when we want to manage memory pointers manually, which in turn means that if we don't manage it correctly, we can cause leaks or even crashes. For more information on this topic, visit this video's resource page. Once we've created our UnsafeMutable Pointer, we'll add the following lines to our viewDidLoad. The first line allocates a space in memory for our string. The next line initializes our value to faucet. And next, we set our variable to nil. If we left our program as is and ran it, we'd create a memory leak since we haven't destroyed and deallocated the object before setting it to nil. To avoid a leak, we'll start by moving our nil assignment up to our Handle Create Zombie Tapped action, and then we'll insert two lines just above it. This first line deinitializes our object, much the same way as we can deinitialize an object using a deinit method in a class. The next line here actually performs the deallocation. This is what Arc actually does for us when our reference count hits 0. This code is now properly deallocated, and as is will not cause an issue. Now let's create a zombie. Just duplicate your dealloc line and place it below the original. Let's build and run our application. Once your application is loaded, let's tap Create Zombie to see what happens. The application crashes and it shows us right where the problem is. This is one method of creating a zombie. Let's see how this looks in instruments. We'll need to change a few settings in Xcode before we can get instruments to report on zombies. Click on your active scheme. When the dialog appears, select Enable Guard Malloc, Enable Zombie Objects, and stop on Debugger and Debug Stir. Then click Close. Run your application and, just as before, let's click Memory in our Debug Navigator, and then click Profile in Instruments and Transfer. We see our application running fine. Recall that our object was created on launch. Now, when we tap Create Zombie, our application will crash and instruments will report the NSZombie leak. The second way to create a zombie is by trying to reference the deallocated object. In order to test this, you can simply remove the second dealloc call and replace it with an assignment call like this. Again, this is something that you're unlikely to encounter in Swift unless you're working directly with Objective-C or C. In this video, we have created a zombie and saw how we can detect it in instruments. In the next video, we'll look over 8 tips to improving memory performance in our applications.